We are back at this carrier unit where one of the stages, first stage compressor, was short to ground. So we unhooked it and we left it running single stage. I'm here today and fans are running. We got no compressor either stage. Well, let's see what's going on. It's cold to the touch, so this is our first stage that we have isolated. Second stage compressor is not warm. Well, it's a little warm. Well, it's a little warm down here, but that's the crankcase here. The compressor itself has not run at all. Everything is ambient, which is cold. Even the discharge line is very cold. Let's check the control section. Let's look for anything obvious, and then we'll check it for pressures. It is a cold day out here, so they have conditioned makeup air, but it's set for 75. So I'm gonna bump this down so that our conditioned makeup air kicks in to help with the temperature in the kitchen whilst I'm monkeying with this. Because I don't always trust the board. This is first stage cooling. Black and blue. Black high limit, blue low limit. Low pressure, right? Second stage, it looks blue, but the underside, it's purple, and just like this. So this is orange and purple on the second stage. So correct. Orange on the low pressure, purple on the high pressure. Black and blue on first stage. Again, first stage, we know, isn't gonna do anything. Second stage, I just heard it kick on. So it can work. I tested, I've got 24 volts. Sorry. And it's raining. Gotta love it. So Y1 to common. Right, we're calling for cool. Y2, obviously we're calling because there's a jumper. So Y2 is energized, it should be running. So this is my Y2 contactor. I got no voltage at the coil, so it's not a contactor problem. I'm off on a safety. Let's go through this real quick. Let me re-show you where my mind is at. Y2 to common. 24 volts. So, what's supposed to happen now is the board is going to run out of the low pressure into the low pressure, out of the board into the low pressure, back from the low pressure in, out to the high pressure and back. Once that 24 volts makes it all the way across, home run, the contactor will start. Here's the catch. Let me show you on circuit 1, because circuit 1 has no gas in it, but it's calling. So on out to the low pressure, we got 23. Coming back, we got nothing. Circuit 1 is off on low pressure. Also, I have the compressor disconnected. Circuit 2, 0. I'm not starting, and for those of you that think it might start on the other side, look. 0. I have no volts leaving the board to even run through the safety circuit. Do we have a board problem? Again, you've got a smoke disconnect. But if the smoke disconnect was a problem, it would have interrupted the whole system. So imagine I take this 24 volts that's sitting here, I've got it jumped to there, and second stage pulls in. I haven't bypassed the safety. I've bypassed the intelligence of the board. I'm basically gonna run Y2 off of Y1 in the capacity that I'm taking the 24 volts that the board should be sending out for it to prove its low pressure and then prove its high pressure. And it's still being proven. So now, what I mean by that, I'm sorry, bear with me. All right, now I got 24 volts going to the low pressure, and the low pressure says, yep, you can run. Then through the board to the high pressure, says, what do you think, high pressure? High pressure says, yep, you can run. and the contactor pulls in. So I need to put a jumper between circuit 1 and circuit 2, and this is a bad board. Or there's a bad wire in the board, right? Like, there could be a bad connector somewhere. I hate just condemning boards, because you order a $200 board, you put it in, and the unit doesn't come back to life, and now, you know, you're eating crow with the owner saying, oh yeah, no, I promise, I really do know what I'm talking about. I just, I need to order more parts. I hate that guy. And I'm scared to death of being that guy. So anything I can do to prove what's going on, right? I'm gonna look at the schematic here, and I'm gonna do some deep dive stuff to see what it is I might be missing, because somebody pointed out yesterday, you know, I am no super tech. I don't pretend to be a super tech. I never even went to trade school. I've just been up on these roofs for a lot of years, touching all this equipment, learning by fire, and getting burned sometimes. So I don't know what I don't know. That's why I love this YouTube with y'all, because one of you will look at this and go, oh man, Joe, it was XYZ, and then I've learned something new. So yeah, I talk a lot of crap when I find stupid stuff, because guess what? It's YouTube that's good for views. But yeah, so this is what we're doing for the moment. I've got the backup running a little more in the kitchen. I've got second stage. I will put gauges on it and check how it's running. I just didn't want to do gauges yet unnecessarily. But I got a nice hot discharge. I got a nice cold suction. So we're definitely cool. Let me close that up so we don't create a problem. Let me do some homework. See if I can find any pearls of wisdom. And why is stage 1 compressor dead and out of gas? Everything else is dry. Just this one little spot. Also, look, the metals become hydrophobic. Water won't stay on it. That's because there's oil. This is a refrigerant leak, which is real crappy. We'll have to throw a bunch of nitrogen in this thing. Not today, but I'll have to throw a bunch of nitrogen in this stage, shut it down, and give a listen. Hopefully it's on an outer coil. We can cut the fins back and fix it. Otherwise, this just became a very large single stage 15-ton unit. Let's walk through this real quick to see if I'm being dumb. Compressor 2, C2. So this is what we're talking about. So we're not worried about the actual power of this. We're talking about the control circuit. So now we got to find C2. All right, so here's C2. All right, on the brown side, we have brown and orange. Yep, we got brown and orange. So on the brown side, to C2, it runs, I'm gonna go backwards through the outdoor fan relay, which is functioning because my outdoor fans are on, from 7. So when I measure 7, I get 24 volts out of that. Also, it has to clear through the high pressure, the low pressure, and what is that? The indoor relative humidity, which that's set for calling, so that's irrelevant. That's good. So I'm clear on my brown side. On my orange side, I go through an FIOP, which is factory installed option, COFS, which is condensate overflow switch, so not dealing with any of that. So that's no. And then we're back to FPT2, which is your freeze protection thermostat, right? So that's just bolted to the evaporator so that if the evaporator totally freezes up, the unit shuts itself down. And that runs out of orange number 6. So I actually checked, my battery's dying, so I turned it off. So out of orange number 6, I got 22 volts. This is my freeze protection. So I got 24 volts out, I got 24 volts back. That's good. So the entire system of safeties is functioning. Because again, I took the first stage circuit and just sent it here manually with my jumper to start the process. The safeties aren't here. The safety communication is here. But it is all running out to its appropriate high limit, low limit, smoke detector, blower motor relay. Like, everything is functioning. The only thing that's not is this board is not sending its 24 volts to the second circuit to play. I'm back to saying it's a bad board. But I don't need to replace the board for now because I'm only running one stage anyway. If I wanted to get real fancy, I could actually undo this and just wire up the physical second compressor and second safety circuit to the first circuit. And by all rights, the system would be running single stage all the time with the circuit that's viable. I may do that. I just don't like to flip-flop the entire system because I am no super tech and there's going to be nuances in here. I wonder, do I have an economizer problem? And the reason second stage isn't kicking in is because the economizer has got it shut down. But no, there's no intelligence here in the economizer. There's an economizer temperature probe over there, but I don't see any with the little manual control. And there's nothing about those settings that change. So, boo. I mean, hooray, I'm gonna just make a correct jumper so this doesn't stay this way. And we're gonna roll. But boo. All right, after some consideration, the easiest thing to do was this. See it? This is just an output from the board. So is this. So I took what the board thinks is first stage, which is irrelevant because they're jumped, but the board thinks first stage, when it energizes it, it's sending the control circuit physically through the second stage. It leaves here and comes into there, across to the high, out, through the fan relay, through the freeze sensor, and second stage pulled in. So that'll keep us running for now. And our kitchen will be back under control.